Now, another important topic of forecasting is to tell whether a model is doing better than the other. As you saw, we have many forecasting models. We have moving average method, we have naive method, we have weighted moving average method, we have a fit model, we have a seasonality model, trend model, and decomposition model. So there are so many models available, and which one is working better than the others. Although we can make it very complex and complicated, that does not mean it enhances the accuracy of the forecasting. Sometimes, simple model works better. We thought about the exponential smoothing model, or even in linear regression, we have a simple linear regression or logarithmic regression or polynomial regression, and which one works better. And we thought, the simple, although there's just only small difference, simple linear regression was doing better than the others. So we should be able to tell which forecast model is doing better. In linear regression, we can tell it by R square, but in time series model, how can we tell the difference? That's the question that we should ask and should be able to answer. To do so, we need to look at a few models, and there is a forecasting error concept first. To tell whether a forecasting model is doing better than the others, the essential measure that we need to look at is forecast error. Forecast error is defined as the difference between actual demand and forecast values, or AT minus FT. That's a forecast error. And the lower forecast error a model has, the better it is in terms of its accuracy. And we have several measures to analyze that. The first one is mean absolute deviation. That is, you take absolute value of the difference of actual demand and forecast value, or forecast error, and add them up and divide it by n. That gives you MAD, or mean absolute deviation. Another one is mean squared error. This one amplifies forecast errors. So square it and then sum them up and divide by n. Doing so, it amplifies the forecast errors and see the difference between the models more clearly than MAD. The last one is mean absolute percent error, or MAPE. And MAPE is most intuitive measure for us to understand because it tells us the percentage of the error in comparison to the others. Say 10% of error, 5% of error, or 1% of error. So it's much easier for us to understand that measure in comparison to MAD or MSE. Here's an example. Say we have this forecast. We have actual tonnage, the unloaded data right here. And we use the moving average with alpha equals 0.10 or alpha equals 0.50. And 180 is actual demand, and this is forecast with this model. So the absolute deviation is absolute value of 180 minus 175, which is 5. And similarly, 180 minus 175 gives you 5 for this second model. And if you go to quarter 2, 168 minus 175.5 gives you 7.5 of absolute forecasting error. And similarly for the second model, 9.50. So you have different forecast error, absolute value of them for model A and B, and you add them up, right? So 82.45, so you can tell that this is lower than this. So MAD 10.31, 12.33, 190.82, 195, 2.24, and 5.59% of error and 6.76% of error. So all these three measures tell you that the first model, alpha is 0.10, less sensitive to the past changes, is better than the sensitive model that you can tell right away. So if you just compare these two models, the first model is better and better forecast, you want to go with this one. So this is how you tell the accuracy of the forecasting model. Another thing that you want to look at is tracking signal. After you choose a certain forecast model, and you should be still able to tell whether this model is working or not, because sometimes your changes happen and it goes out of your boundary, and those are something that you did not expect before, and you should be able to tell when that is happening. At that time, you are going to be using this tracking signal defined as running some forecast errors divided by MAD, and that is running some of forecasting errors simply the summation of forecast errors, and it could be either positive or negative, and because we did not take the absolute value of them. And you have to divide it by MAD that we have discussed just now. And MAD is defined as absolute value of forecast error and sum them up divided by N. And you are dividing RSFE by MAD and see where it is standing. And if it is within plus minus 4, is pretty good. In high volume stock items or industry, if it is staying plus minus 4 range, then the experts say it's a pretty good forecast model. If it goes beyond plus minus 4 in high volume stock item industry, then you can tell that your forecasting model is going out of control, is not performing as good as you would like to see. And if it is a low volume stock item industry, then it's going to be plus minus 8. That's acceptable usage that you can use for tracking signal. So by employing tracking signal, you can tell whether your forecasting model is performing good or not. So in this forecasting model, which is really important analytics skill, we have learned how to understand when to use various forecasting models. We have moving average method, weighted moving average method, exponential smoothing method, fit model, and trend model, seasonality model. We have learned linear regression and decompositions. And when are we using all these models, right? That we have learned. And we also learned how to apply those models to real data using Excel that has been done together. And thirdly, we have also learned the measures of accuracy of forecasting and tracking signal that is used to monitor the accuracy of forecasting. I hope this lecture was helpful for you to understand what forecasting is, and thank you so much.